Hello and welcome back to this session on the interpreter design pattern. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The interpreter design pattern is a behavioral design pattern that defines a language or grammar and provides a way to interpret and execute sentences or expressions of that language. It is used to solve problems related to language processing, rule-based system, or domain-specific languages. The interpreter design pattern allows you to define a grammar for a language and provides a way to interpret and evaluate the expression in that language. It is often used in scenarios where you need to process or evaluate textual expressions, query languages, or configuration languages. The pattern involves representing each grammar rules as an object or class, with each rule typically corresponding to a specific operation or behavior. The grammar rules are combined to form complex expressions or sentences, which can then be interpreted and executed. Hello and welcome back. Let us take another code example of a shopping cart context using the interpreter design pattern. We will be implementing a simple language for calculating the total cost of a shopping cart based on the quantity and price of item. The shopping cart will be the context in this example. The shopping cart holds any necessary data or variable that are required during the interpretation process. You can see right here, the shopping cart has a dictionary of items. I'm going to call this shopping cart alone. It's actually the context. And then the shopping cart context takes in add item to add a new item into the dictionary that stores the current state of the data. And then I'm also going to have another method that is called get item. The add item takes in the name of the item and then the quantity of the item, while the get item just returns the quantity of the item that is added. So the context in this instance represent the current state or context in which the expressions are being evaluated. In other words, it holds any necessary data or variable that are required during the interpretation process. Then we have the abstract class or interface that all expressions will implement. And then I'm going to start with a terminal expression, and that will be called item price. And then I'll have a non-terminal expression, which is addition and subtraction. So I'm going to implement the terminal expression, the item price, which takes in the name and the price of the item in the cart. So it is initialized here, name and price. And of course, because inheriting the expression, I'm going to be implementing the interpreter. The essence of the item price terminal expression is to return the total price of the item in the cart. So what I'm going to do is, first of all, to get the quantity of item, I have in the interpret method the context, which is this. I'm putting in the context, that is the data. And I can then get the context item method, and that will return the number of items in the cart. So having done that, I'm just going to return the price of the cart multiplied by the quantity. This item price return the total amount of the specific item in the cart. So we'll give it the name of the item, which is stored in the context, and then we'll multiply it by the price. Now that we have the terminal expression, we're going to instantiate the addition. We want to add all the items in the cart. I'm going to have the expressions. The expression will take either the terminal expression or the non-terminal expression. For addition, we're going to implement the interpret method, and the interpret method returns the expression interpret method, and then adds also the second expression interpret method, which takes in a context. If we want to get the subtraction non-terminal expression, we basically do the same thing. We just copy this. That is, we initialize two expressions that we want to subtract, and then this returns whatever value comes out of any of these operations. It then implements subtraction on it. Let's implement the client, and we're going to create the shopping cart basically because we want to create the data that we'll be working with. And what we'll do is that we'll add three data essentially. So we have three items in the shopping cart: 2 mangoes, 7 paper roll, and then 3 deodorants are added to the cart. Now let's create the expression, and in this expression we're gonna do an addition of two of the expression. The first expression will be the item price, and of course this item price will calculate 3 deodorants at $15 each. And because this takes in just 2 parameters, this is the first parameter, which is an expression. The second parameter is an expression. So we're going to put in another add, and in that add, we're going to put in 2 more expressions. So right here, I have 3 items that I am adding together. So having done that, we can now just calculate the total expression. This expression, we're going to interpret the expression so that the calculation can be done into the variable total cost. And we can just print that out to see what the value will be. I'm running the code now, and it's giving me some error on line 23. Let me look at line 23. It said get underscore item. It has no attribute like that. Yeah, it's supposed to be get underscore item. I'm going to take out 1 underscore. Yeah, and then you can see the total price is adding together. All this price is being added together to give you $76. And if you do the maths, you would see we have 3 deodorants multiplied by $15 each will give you $45. We have 7 paper roll multiplied by $3 each, and that will give you $21. We have 2 mangoes multiplied by $5 each, which is $10. If you put it together, 45 and 21, 66, and this, and that is $76. So it adds it all together using the interpreter design pattern. So $76 is a combination of these three: $45, $21, and $10 added together. It doesn't have to be addition. We can change it to subtraction. So let's say we change this to subtraction. You see, it changes to $14, because what that does is that it takes the first one and then subtract it from the addition of the second and the third. So it subtracts this expression from this expression. And if you calculate it, it's going to give you $14 altogether. The interpreter method allows us to use this expression to do whatever calculation we intend to do. The interpreter design pattern creates a language, and this language or grammar provides a way to interpret and execute sentences or expression of that language. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The course is called Design Pattern in Python with Real-World Code Examples. We showed via practical coding how design pattern is implemented in real-world scenarios like event manager, cache, database connection codes, document management code, creating optimized configuration settings, login frameworks, GUI framework codes, plugin systems, game development codes, payment gateway, document generators, computer graphics generation codes, financial model code pattern, resource pooling, object pooling in ORMs, website creation, database query codes, language translator, web application framework creation, banking system codes, organizational chart creation, file system, interpreter, menu system, text formatting code, authentication code, authorization code, API for OS, document management system, create proxies, event handling, middleware in web development, workflow system, undo redo functionality in apps, job scheduler scenarios, parsers, chart applications, drawing applications, notification system, distributed system, booking system, workflow management system, sorting algorithm, file compression utility, and many more. If you are really serious about your career in programming, you have to get this video. And you don't have to be a Python programmer to use it. Use the link in the description to get the best price for this course on the Udemy platform.